So this is a lab called It's All Uphill, and I stole this from, I don't know, from some, I think it's a physics curriculum called Prisms. And what we're going to do is we're going to look at this cart, and we're going to pretend like maybe we're pulling the cart up the hill, right? And the question is, we could pull the cart a long distance up a not very steep ramp, or we could pull it a short distance up a very steep ramp, right? And so when we talk about distance, that column that says distance, it's not the length of the board properly, it is actually that it is from where the board touches the ground to where it touches this thing, and that of course changes. I had a kid one time do this lab, and he's like, the board's length isn't changing. And he's moving the thing up and down like this. No, it actually is like, right now it's 60 centimeters, right, is the length from there to this point, right? And now it's 50, now it's 40, now it's 30, now it's 20 or something like that, right? Okay. And then what you're going to do is for each one, and this takes a little bit of teamwork, right? Have somebody hold this thing, right? Have them hold it like that, and then for that steepness, and I think the 5 Newton scale is the one you want to use, okay? Before you use them, make sure that when you hold it in the direction you're holding it, that it does read 0. Okay, to do that, you slide this little metal plate like that. Right? So if I'm going to hold it like parallel to that plane, slide it so it reads 0, and then put the thing on there. You're going to put the card on there like this, and just see what the force is that you need to do. And what I would do is I would pick distances and steepnesses so that you could always use the 5 Newton scale, right? So if that means moving this ramp down a little bit, right, so you can use a bunch of distances, that's okay. Notice that, of course, well, you'll see, I don't want to spoil it for you, but you might guess what happens as the ramp gets steeper, right? You know, what happens to the force. And then, ultimately, what I want you to do, put the force that you measure, the distance, and that distance is, again, it's the distance from, right? It's the distance from here to here, right? That's going to be your distance. The force is what you measure parallel to the plane, right? And then I want you to multiply the two together. Yeah? Okay? And then get something that's force times distance. This has some meaning. We're going to learn about this today. And then the two questions are, what is the relationship between force and distance? What do you notice about the third column? Is there something that's true about the third column? What do you think it means? Okay? Every man, woman, and child should have their very own little sheet, but we don't have that many boards. I'll try to rustle up some more, but and they're over there. If you can't do it on a countertops, the countertops are pretty full. Go do it on the floor. You could do it right outside in the hall. And then the added benefit of that is that you could check out all the blood spatters on the walls. It's kind of a neat thing. I tried to get them to